Hello. Now that we know how to construct signal flow graph and we know the definitions under these concepts, the next thing that we will be talking will be how do we solve them? So you know how to draw them now. Do you know how to solve them? In solving a signal flow graph, it's possible to simplify them in the same manner as we did in a block diagram reduction, but it will be more time consuming. And the other way to solve them is to use a formula by inspection from the original signal flow graph. And that formula was derived by, they call it the Mason's gain formula. And if you want to solve for the control ratio, C over R, is just equal to the summation of a certain something here. I'll explain later what are this pi times delta I from n equals 1 up to I all over we have another 1 delta. So this is called the Mason's gain formula, or they also call it the general input output gain formula. And what is P here? Pi or Pi, I here is, this is the number of forward path gain. So I is the number of forward path gain. And we already know what's a forward path gain. So it's just the product of all the gains from the input to the output. That's the forward path. So Pi is the gain. This is the I forward path gain. This is the actual gain. Then we have delta here. So delta here is evaluated. Delta is just equal to the formula for delta. This is just equal to 1 minus the sum of all loop gains. Sum of all loop gains. So loop gains, these are similar with the path gains, but instead of forward path, you're looking for a loop gains. So loop, again, loop, these are path gains or paths that started with a node and ended with the same node. Then plus the sum of all gain products. Gain products of two non-touching loops. Of two non-touching loops. So we already know what are non-touching loops. So if you sum all the products of these non-touching loops, two non-touching loops, then this will be here. Then continue this one. The next one here will be minus. So instead of 2, the next one will be 3. If it's possible that there are 3 non-touching loops. So you do that again, but this time this should be 3. 3 non-touching loops. And so on. So plus dot, 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 until how many possible loops that are touching and untouching. So in general, in mathematical formula, this is just, we write this one as 1 minus the summation of all Pj1. This 1 here means it's the sum of all loop gains. These are just loop gains. J is the number of loops in the signal flow graph. So this is J1. Then plus summation. The next one is products. So this will be J2. So if it's 2, it means 2 non-touching loops. Then minus summation of P J3. So these are 3 non-touching loops plus summation of the product gains of 4 non-touching loops, and so on. dot, plus minus plus minus, and that will be delta. Then here we also have delta I. Delta I, this is evaluated. It is the delta. You take delta evaluated, eliminating all the loops touching that path, a forward path. So if it's delta 1, then the forward path 1, P1. Delta evaluated with all loop gains or loop touching the forward path with respect to the delta I eliminated. So take this delta, remove all the loops that are touching the forward path. And usually this, the answer for this delta is usually just 1 because most of the time the loops are touching the forward path. So these are the variables here. Now, let's prove if this is true or not by solving a simple block diagram. So our simple block diagram, the canonical form, we already know this. So plus minus. So this is our input R, we have an output C. And this is G, and this is H. So we already know this one. This is the canonical form of a block diagram. And from our previous discussion, this is just equal to G all over 1. So this is, if this is plus, then this should be plus minus G times H. So now we will try to solve this using signal flow graph. So the first thing that we will be doing is to convert this into a signal flow graph. So how do we do that again? We take points, 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 and points. So we have 1, 2, 3, and 4. We have 4 points here, or 4 nodes. So we have 4 nodes, 1, 2, 3, and 4. So what are these nodes? The first one, we have our input R. Then this will be going to the second node here, the summing point, and there's no block between that input and the summing point. And next, the summing point here going to another point here, this takeoff point, and there's a block between the two, and that block is just equal to G. Then again, from this point to the output, we have a straight line. There is no block between them, so this will be equal to 1. Then we have a feedback from this point is this one, going back to point here, this point here. So this will be in that direction. And that is just equal to H. It can be plus or minus plus here. Minus plus. And this one, this node here is just the output C. So this is the signal flow graph. Now, we will apply the Mason's gain theory or formula here. So the first thing that we will be looking at is the forward paths. How many forward path do we have? We only have 1. Forward path is the path connecting the input to the output directly. So this is the forward path. And what's the gain of that forward path? So we only have 1. So P1, Pi, I is equal to 1. Then P1, what's the gain of that? So 1 times G times 1. And that is just equal to G. So that will be our P1 here. Pi, forward path gain. We only have 1 forward path. We cannot go back here and then rotate again. Because remember the forward path, you cannot pass through 2 nodes more than once. So it's not considered a forward path. But we have a loop here. We can consider this one as a loop because if we start here and we go in this path, then we end up with the same node. That's a loop. So the next one, after solving the forward paths, we can now evaluate delta. And delta, or before we evaluate delta, because the delta is equal to, remember the formula for delta, 1 minus the summation of all loop gains here. So we need to first evaluate the loop gains. So before we evaluate that delta loop gain, so this is forward path. Forward paths. Next, how about the loops? So how many loops do we have? We only have one. This one. This is a loop. And that one loop, so if we only have one loop, so P1 and 1, P11. Why P11? Because this is Pj1. Our J is equal to 1 because we only have one loop. So we have just P11. And that will be the gain of that loop. So this is that loop. This is loop 1. So this is 1 here. If there are other loops, loop 2, then we call it P21. If there are other 3 loops, then we call it P31. 1 here, the last one here in the subscript represents that these are loop gains. And the number here represent the how many, or the ith number of the loops. So if there are 4 loops, then we have P11, P21, P31, and P41. But here we only have one loop, so therefore we only have P11. And that P11 is just equal to the product of this, G times H. And that is minus plus G times H. That's the loop, or the loop gain. Next, after knowing the loop gains, we can now evaluate delta, because we only have one loop. We don't have any non-touching loops because we only have one loop. We don't have 2 non-touching loops. So therefore, delta is just equal to 1 minus P11. And P11 is equal to this. So delta is 1 minus plus, and this is minus. It will become plus minus G times H. And that is our delta. Another formula. Now for delta I, because we only have one forward path, so we only have delta 1. Delta 1 is to take this one, you eliminate all non-touching or touching loops to that path. Our path is only one in this direction, and this loop touches that path, so therefore it's eliminated. So this will be 1 minus 0, or simply 1. Then we can now substitute that in our formula here. So C over R now, using Mason's gain formula, C over R is equal to the summation of, because we only have one, P1 times delta 1 all over delta. So this is just the formula. And P1 is G. Delta 1 is just 1 divided by delta, or delta is this one, 1 plus or minus G times H. So therefore, C over R is equal to G all over 1 plus minus G times H. And it's the same thing as our canonical form in black diagram. So that's how we do Mason's gain formula. Now let's take more complicated example, the one that we did from our previous discussion. This one. This is the signal flow graph of the circuit that we did from our previous example. So here, so to solve this, first, remember the formula. The formula is this. How many forward paths do we have? So how many forward paths do we have? We only have one again. We only have one path, forward path, and that path is this one here. Just remove the loops. And this will be our forward path. So this is the forward path. We can call it path 1. So what will be the gain of that forward path? So P1, this is P1. We only have 1. So the gain will be just the product of the gains here. We have 1 over z1 times z3 times 1 over z2 times z4 times 1. So this will be 1 over z1 times z3 times 1 over z2 times z4 times 1. So P1 is equal to, this is z3 times z4 all over z1 times z2. So that's our P1. For the next thing, the loop. For the loops, so how many loops do we have? We have 3 loops here. So we have 3 loops. And we can call them, so this one, I can call it loop 1. I can call this one loop 1, this one loop 2, and this one loop 3. So next is P1, 1. Because we have 3 loops, we need to solve for P11, we have P21, and we have P31. So these are the loop gains. Loop gains. So P11, P21, and P31. So where's P11? That's the loop, the gain of loop 1. So loop 1, we have Z3 times negative 1 over Z1. So this will be negative Z3 over Z1. Then for P21, for the loop 2, we have the gain is 1 over Z2 times negative Z3. So this is negative Z3 all over Z2. And lastly, for P31, the third loop, we have Z4 times negative 1 over Z2. So this is negative Z4 over Z2. So these are the loop gains. The next, so after solving the loop gains, P31, the next thing that we will be solving is, because we are evaluating delta, remember delta here. Later on, we just take the sum of those gains. So delta is equal to 1 minus, we have P11 plus P21 plus P31 plus, and that's it, P31. Then minus, then plus, what's the next thing here? We have sum of all the gain products of 2 non-touching loops. So in our case, we only have a pair of non-touching loops. And what are those loops? We have loop 1 and loop 3. So loop 1 and loop 3 are non-touching loops. Loop 2 and 3 are touching. Loop 2 and loop 1 is also touching. Loop 1 and loop 3 are non-touching. These are non-touching loops. So we need to add them. We need to add the product of those non-touching loops. So we only have 1 non-touching loops, and that will be P1, 2. P1, 2. 2 here means this is 2 non-touching loops. And for the 3 non-touching loops, we don't have 3 non-touching loops because we only have 3 loops. And we only have one non-touching, so we only have one P12. You can have P22 if there are more than 2 pairs or 1 pair of non-touching loops. So P12. And what will be P12? P12, again, P12, this is this one, sum of all the gain products or gain products of 2 non-touching loops. So 2 non-touching loops, what are the 2 non-touching loops? What are their gains? Loop 1 and loop 3. So what are the gain of loop 1? That's P11. What's the gain of loop 3? That's P31. So P12 is just equal to P11 times P31. Why? Because loop 1 and loop 3 are not touching. We don't include loop 2 because it's touching both of them. So P11 times P31. And we know P11 is negative Z3 over Z1. And we know P31, that's negative Z4 all over Z2. So therefore, P12 is just equal to positive Z3, Z4 all over Z1 times Z2. And we cannot evaluate delta here because we have all these parts. So delta will be 1 minus the sum. So this is, we can factor out that negative because they are all negative and make this one positive. Z3 over Z1, that's P11 plus P21, Z3 all over Z2. Then for P31 is Z4 all over Z2. And the negative is cancelled in here because this is minus is positive. Then plus P12, and this is Z3, Z4 all over Z1 plus Z2. And that will be our delta. And the last thing that we will be solving is, we need in our formula is delta I here. Because we only have one path, forward path. So therefore, we only have delta 1. So if there are two, then you have delta 1 and delta 2. And delta 1 is evaluated from here. So this one, 1. Then we need to eliminate all loops that are touching that path. So if we go back here, this is our forward path. And we know that all loops here touches that forward path. So therefore, it should be 1 minus 0. So therefore, delta 1 is just equal to 1. And we can simplify this delta here before we substitute in the formula. So this will be, we can factor out, or we can have, is this plus? Why is this is plus here? It should be Z1 times Z2. We can take the LCD. Z1 times Z2. We add them all, so times 1 here, so we have Z1 times Z2, and Z1 divided by Z1 is Z2 times Z3, so we have Z2 times Z3, then plus Z1 divided by Z2 here, so Z1 times Z3, Z1, Z3, then lastly, or Z1, Z2 divided by Z2 is Z1 times Z4, Z1 times Z4, and the last term here, this one will be 1 times Z3 plus Z4. Z3 is Z4. Then we can now solve for our transfer function. And C over R. Our C here is V3 and our R is V1. So solving for V3 over V1, V3 all over V1 is just equal to P, because we only have P1 and delta 1, and you divide it with delta. And that is P1. What is our P1? P1 is Z3, Z1, Z2. Z1, Z2, you multiply that with this one. Then we have P1 times delta 1. So I just copy P1. This is our P1 here. Paste it here. Then I copy delta 1 is just equal to 1. So just multiply by 1 all over delta. Our delta is this. I copy this again. I'll put it here. So simplify this now. We can cancel out Z1 to 1, Z2, Z1, Z2. So therefore, V3 all over V1 now, or C over R, is just equal to Z3, Z4, all over this term here. Just copy this one. And paste it here. And that will be our answer. And this is how we do signal flow graph. We can also try to solve the other example, the block diagram. In our example, previous example, you can just copy that here. So this one, this is our equivalent signal flow graph. Just copy this and solve for the C over R transfer function. We already know the answer for that, so we can check it later on. So paste. So another example, determine C over R. So again, we repeat the process. First, how many forward path do we have here? So we start at our input. We can go in that direction. That's the first one. And there is another forward path. This part from here. So I can just label that. So this one is the first forward path. The next one is from here, going towards that, then go back here and go to that direction. So those are two different paths, but they are both forward path. So we have two forward paths. So what are the gains of those forward paths? So forward path gains. So for the first one, you can call it P1, the red one. P1 will be just equal to 1 times G1 times G4 times G2 times 1 times 1. So that's just equal to G1, G2 times G4. And the other forward path, the purple one, so 1 times G1 times G4. Then you go here, multiply it with G3, then 1 and 1. So G1 times G2 times G3. So those are our two forward path gains. Next, for the loop, feedback loops, loop gains, how many loops do we have? This one here, G3, G2 is not a loop. It's not a loop. It's a path. So, how many loops do we have? The small one here, this one, you can consider this one a loop. It starts at 3 and at 3. So we can call that loop 1. Loop 1. And another one is this one from here. Then you go into that and then you go back here. You can call that loop 2. And actually there are 3 loops here. What is the other one? So we already have 2. So other one, we start with 2 again. Then instead of going directly, we go upward here. Then we go back here. Then we go back into the first one. So we can call this one loop 3. That's still considered a loop because you start at 2, you end at 2. So we have 3 loops. So now, what are the gains of those loops? For loop 1, we can call that one P11. That will be equal to, so this is 1, G1, G4, then we have H1, positive H1. So the loop is G1, G4 times H1. That's the loop gain of P11. Next, P21. So for the second loop, so we have from here to here and go back. So here, 1 times G1 times G4. So G1 times G4. And you go to that times G2. Then 1. Then you go back. It's negative H2. So minus H2. And that will be P21. Next, for the last loop, so P31. So for the last loop, so we still have a negative 1, G1, G4, but instead of G2, you just replace G2 with G3. G4, G3, and H2. Why? Because this is the path here. Instead of going through G2, the path goes through G3. So these are the loop gains. Next, are there any non-touching loops? Non-touching loops. Do we have any non-touching loops? So for loop 1 touches loop 3. There are no non-touching loops because this is the bigger loop. It touches loop 1. Loop 2 also touches loop 3. Loop 3 also touches loop 1 and 2. So therefore, there are no non-touching loops. And also, all loops touches the path. So if I solve for delta 1, so here, delta 1 will be just equal to 1. Because all loops are touching the forward path, path 1. And for the second path here, it also touches all of all loops. So delta 2 is also equal to 1. Okay, so therefore now we have our formula for C over R. C over R is just equal to, we have P1 delta 1 plus the summation P2, because we have two parts here. So P1 delta 1, P2 delta 2, all over delta. So we already know P1 and delta 1, P2 and delta 2. The delta 1 is 1, delta 2 is 1. P1 is equal to this and this. For delta, so we can evaluate delta by subtracting. So this will be equal to P1 is G1, G2, G4 plus P2 times 1, because delta 1 is 1. We have G1, G2, and G3. Then all over 1, because the formula for delta is 1 minus the sum of all loop gains. So what are the loop gains? These are the loop gains here. So we take the sum of those, G1, G4, H1 minus G1, G4, G2, H2, and minus G1, G4, G3, and H2. So these are the sum of all loop gains. Then we don't have non-touching loops, so plus 0 on the next one. Then we can just simplify this, and that will be our C over R. So how do we simplify this one? We can factor out G1, G2, and in the numerator, so G1 times G2, and we have G4 plus G3. All over the denominator, we have 1 minus G1, G4, H1. Then this will become positive, negative, negative. G1, I can just rearrange this, G2 and G4, H2. Then again, plus G1, rearrange this again, G3, G4, and H2. Then this will be our C over R. And if we look at our answer from our previous example here, diagram, C over R, this one, you can just copy and we compare it with our answer here. So this is the answer in the black diagram. And wait. We have a correction here. I have a mistake in the forward path gains, G1, G2, G3. So let's check that out. It's P2. So where's P2? Here. P2 from here, 1 times 1, G1, G4. Why is it G2 here? It should be G1 times G4. Then we have G3, and you go back there. So it's a typical error. It should be G4 instead of G2. So if I change that to G4, so if that is G4 here, this is also G4. And if this is G4, instead of factoring out G1, G2, we factor out G1, G4. And we have here G2 plus G3. So that it's the same as our answer in the previous. And also here, this part, the final answer here factors out G1, G4, and H2. So G1, G4, and H2. So we have G2, the remaining term here is G2, and the remaining is G3. So this will be our final answer, and should be the correct answer. And that's how we do signal flow graph using Mason's gain formula.